So thank you very much. The current speech is about object detection for bin picking in 3D and AI. Maybe not everybody knows us or knows EVT, so maybe a short introduction to EVT, and then I go ahead to the main course. So we are. This is a short overview. So we are located in Karlsruhe, Germany, and we have also subsidiaries in Korea and China. And our main product is software. Software means we have a general software to do any kind of vision, including 1D, 2D, 3D, thermal and hyperspectral vision. Today, we have a short look to these different technologies and why we use 3D and AI for bin picking. So this is only to give you an idea what the software can do and where the software can be used. And based on that, today we have a look to 3D for image capturing, and based on the 3D and a color image, we generate robot vision solution. The EyeVision software mainly is a graphical programmable software. So here we can see it on the left side. There you have, let's say, kind of recipe which does the task, and you have always a chance to operate on these different images. Here you see three images. One is a color image. The other one is a point cloud. And finally, the question is how can we pick stuff from, in this case, is a palette. It could also be a bin. To show you, the main problem is if you use simply 3D, then you cannot separate the parts. On the right side, you see on the upper image, there is nothing which separates the 3D, which gives you an option to separate in 3D the parts. And of course, with a gray camera or a color camera even, you cannot do it. Of course, maybe with some algorithms you have an option to separate the shapes of the containers here, but finally, it doesn't allow you independently of the parts to grab them. The idea then is how to get it done. And I think you heard today a lot about it. We use AI. AI allows you, with a short training, to separate the parts, in this case in the color image. And based on this, you can use the point cloud to operate on it. How we do it? That it's also fast and easy to use for our customers. We have pre-trained networks. That means networks which know something. For example, they know maybe fruits, pills, screws, or whatever, or boxes. And these networks, in many cases, simply work immediately without any additional training. So the software can directly recognize an apple and give the software the idea where the apple is or what kind of apple is where. We have this small demo which you see on the right side. Oh no, it's not here. In the next slide. So let's go to the next one. So here we have this small demo here on the show. Here you see a lot of boxes, and the idea is then simply you use the color image for the AI. So the AI simply recognizes the different boxes, and to grab it in the room, so if they are stacked together or in any shape, we use the point cloud at the same position. So the idea is you simply use the point cloud to define the grip point of the part. So if it's in a box or if it's on a flat place, it's exactly the same thing. We recognize in the color image the part, and then we go to the point cloud and grab it. And how does it work? Simply, somewhat easy. You register the point cloud and the color image together so that you can switch between the two informations between the both images. Either the simple way is you have a camera which generates you both a point cloud and a color image. How to get these? Either you buy a camera from IDS, Basler, or whomever who can do that. In 3D, for example, if you want to start with it, you could use an Intel RealSense, which gives you this information. But if you want to go more industrial, you can use, for example, a Photoneo or a Civet sensor, which also generates you these images. Or if you don't want to use a ready-made sensor, you buy a color camera and, for example, a time-of-flight sensor from whatever manufacturer, and you simply register the two images. And based on this registration, you are then able to interact between the two images and generate the gripping points for the part. The next important step is, of course, you can also use, instead of a color image, a thermal image or a hyperspectral image. It depends only on the neural network which you use to recognize the parts. The networks are the basic idea, so that's why I have, if you use two separate cameras, you can use, for example, a gray color or thermal or hyperspectral camera, and a 3D camera like a shape drive, for example, or any triangulation camera would also work. It's not only reduced to a single shot image, you can also use a scanned camera. Or, of course, finally, the easiest way is if you use the ready-made camera like Civet or the Photoneo, Percipio, and many more. There are so many cameras out there. One of our main tasks is to enable our users to use whatever camera they want. Therefore, we have integrated in our software all these camera manufacturers. So you simply select the cameras, either a separate one or a combined camera, and then you can directly start with it. And based on that, you can go ahead. You have the two images. You use one pre-trained network. And based on this pre-trained network, you do the object recognition. If the pre-trained network is not working, of course, you immediately have the option to use the integrated transfer learning. That means you use one of our pre-trained networks and you add your part or your object to add it to the network. The advantage is the time to market is faster. If you train a network from scratch, maybe you need multiple days and many thousands of images. If you use a pre-trained networks, you need maybe 100 images. And with some integrated augmentation, you can train the network immediately, and you are ready for to go and to work with it within, let's say, 1 hour or 2 hours with the new part. So if you have a box, use our box networks. You have to separate the box. You simply train the new box to it, and you're ready to go. Or if you have a box of screws and we don't know your screw, you simply train these screws and you can directly work with it after a short training phase. The other important thing is then, of course, we do the registration between the color and, let's say, gray color, thermal or whatever image with a 3D camera. And the next step, to do the grabbing and to do bin picking. So bin picking was one of the options, but you could also, of course, do depalletizing, palletizing, or gripping parts from anywhere, you need a hand-eye calibration. You have to register the robot coordinate system to the camera coordinate system so that the data which the vision software generates can be used directly with the robot together to do the gripping operation. This all is integrated in one package, which allows you, without programming, to do the solution. That means you can directly start with your solution to solve your tasks. Here I have the first image, or one of the first images, again, simply to have a closer look to it. If you simply use a color camera, then someone who knows how to operate on these images, he knows it's really difficult to solve these tasks with only a 2D algorithm. Of course, there are a lot of matchers in the market, but the matchers have all their problems depending on light and whatever situation, especially if you don't see the shape very well. And the same happens if you use a 3D point cloud. If you have the same height of the parts, it's very difficult to separate them. So if you cannot separate it in 3D or 2D, you cannot grip it. The solution is, at the end, the AI. So, of course, everybody talks about AI, but AI is that small part which allows us things to solve which were nearly impossible a few years ago, and allows us today to make these solutions. Here is another nice example of depalletizing or gripping parts out of a box. We have multiple card boxes, and you see these are our camera viewers, but you see here the different boxes, and you see also it's not the best lens which is used for this application. So we have a big distortion inside, but even for this one, you get a real, the AI allows you to get a clear recognition of the parts, so that you know where is the box and which orientation is the box, so that we can do the gripping operation later than in the point cloud. And of course, if you have these kind of boxes, and of course maybe not all are recognized, you simply use our transfer learning, which is integrated in the software, to add the box which is not recognized. So you need maybe 100 images, which can be done directly by the system, and you feed it into the transfer learning algorithm, and then you have a new network which knows this new box, or whatever it is. It could be any kind of bottle, food, or whatever. Another nice example, which we have here on the show, is to recognize fruits. Of course, we have a fruit network, and it works with all kinds of fruits to grab them. But we all know there are so many fruits, we cannot train all fruits. That means if you grow maybe tomatoes or whatever, of course, tomato we have in the network, but you grow anything which we don't have, you simply take the few fruits of them, capture the images, and then you feed it directly into our transfer learning part of the software, and as a result, you get a new network which recognizes then the new fruit which is in the network which you trained additionally. So this means you have a direct workflow. You can start immediately. You don't have to program in a programming language. You only do drag and drop programming, and with this you make the solution in all steps, from image capture, from whatever camera you want to use, maybe IDS, Basler, and all the others. You can download the software and can test it by yourself. There's a big list of all 3D and 2D cameras inside, so you can test it. As an easy example, which I said before, you also can use, for example, the Intel RealSense. It's an easy access for everybody who want to try to do bin picking or palletizing or whatever. It's a cheap sensor, easy access. If you need a reliable sensor for your machine, later I recommend any industrial solution then. But for easy steps, you have a way to it, and you download the software and you simply test it. So here, I see that the time is running somewhat fast. Here, another example, simply try the software and test it. I show you shortly only how to recognize parts, how they look in 3D. And you see, for example, if you do machine vision, this is not an easy task, even if you have some glance about how to segment these kind of pictures. It's really difficult to do the segmentation. And for the summary, for really easy bin picking, it's much easier if you use this combined technology, because it's because you get two kind of information. So one, to select the part, even if it's shaped and it's difficult to segment it in 3D, or you and then use the 3D and the hand-eye calibration to make the solution with the software. And of course, you have a lot of options of cameras and robots which are supported and which can be easily, based on the SDK, added to the software. So, but I think normally you find all kind of solutions for the software. Maybe one, if you do deep learning, we have now also Python, so you can also add your additional code to Python. If you want to test it, you simply can contact us, or you can download the software from the web and test it by yourself. I recommend it. You get also this ready-made project, which allows you directly to do the tests by yourself and see how it works. So that was my 20 minutes, and of course we have no time, so I leave the stage, and if you have questions about the software, I'm there and I'm happy to answer them.